Hi, a random sample of 10 observations is taken from a normal distribution with a known mean, mu, and a known variance, sigma square. The results are shown below. Calculate the value of the sample mean and an unbiased estimate of the population variance. The second part, test at 2.5% level of significance the claim that mu is greater than 20. So for the sample mean, what we basically do, we add all the values here. We get summation of x, which is 207.7, and then that's going to be 200.7 divided by the sample size. And so we get then 20.77 as an answer. And then for the unbiased estimate of the variance, we use this formula here, which is n over n minus 1 into summation of x squared over n minus summation of x over n to the square. That's basically the mean to the square over here, which comes to 5.27 as the unbiased estimate of the variance. And for the second part, we need to test at 2.5% level of significance the claim that mean mu is greater than 20. What I'd like you to realize over here is that this is a very small sample. So if it's a small sample, we're going to use the t-distribution over here. Yes, a t-distribution, and with a 2.5% significance level, we're looking at a one-tailed test. One-tailed test, okay, to the right hand side of the distribution curve. So here we are. And so because it's a small size, we have n is equal to 10, therefore the v degrees of freedom is going to be equal to n minus 1, which is 10 minus 1, and that's going to be equal to 9. So the v degrees of freedom is 9, and our value of p, because this is 2.5, is going to be equal to 1 minus 2.5 over 100, basically making it 0.975. So we're going to look at 0.975, and we're going to look at this value here from the t-distribution table. So from our table, we're looking at 0.975, and here's 0.025. Okay, so 0.975, and I'm looking at 9. The v degrees of freedom here is 9, so that's going to come to 2.262. So basically what I have is over here 2.262. I also need to find the test statistic, and before I do this, I'm going to formulate my hypothesis. So I have the null hypothesis, where I would say HO is such that the mean is equal to then 20, because that's what's been given in the question. And for an alternative hypothesis, H1, the mean should be greater than 20. That's what they want, greater than 20. And so for the test statistic, it's practically the same as the normal distribution, Z distribution. So over here, I've got so the sample mean, and the sample mean was calculated from part A of the question as 20.77 minus the mean, population mean 20, divided by us. We don't know the standard deviation, but we did calculate the unbiased estimate of the variance, so that was 5.266. So I'm going to say square root of, divided by square root of 5.26677 and so on, and all of that over the sample size, which is actually 10. So a test statistic will give us a value of of a value of 1.061006956, the other decimal places become insignificant. So this is our test statistic. Now we need to look at the test statistic and see where it falls. Now 1.06, and this is 2.2, our critical region here is 2.262. So the 1.06, this is where HO is accepted and H1 is accepted. So the 1.06 is going to fall somewhere here. So it is outside the critical region. So because this one here is less than 2.2, is less than our value here, 2.262, therefore it falls outside the critical region. Hence, HO is not rejected, so there is insufficient evidence, right, to suggest that the mean is greater than 20. Hence, there is insufficient evidence to suggest that mu is greater than 20. I hope you've been able to enjoy this and take as much as you can from this video. Take care. This is what we've done here for our t-distribution.